Hello class, welcome to exercise 10b, the laws of logarithms. Your pre-learning in your examples today will be example 4, simplifying logarithmic expressions. And the pre-learning for this example is questions 1, 2, 3 and 4 in the new book and 4, 5 and 6 in the old book. And then you have example 5, evaluating logarithmic expressions. And the pre-learning for this example is 5, 6 and 7 in the new book and 7, 8, 9 in the old book. And as always, you don't need to do all 60 parts to those 7 questions. Half of that would probably be enough, but make sure you do some questions that you find challenging in that mix, all right? So this is another lesson on skills for logarithms. And if you're going to learn the skills that we're covering today, it's vital that you have the index laws pretty much memorized. All right, let's get on with the introduction. Now, in our last lesson, we learnt that log base a of x equals m is just the same as saying x equals a to the m. So if we let x equal a to the m, and we also have this y equal to a to the n. So then by definition, log base a of x equals m, and log base a of y equals n. And importantly, for what we're about to do, these are equations. And because they're equations, the reverse is also true. So I'd like to write out explicitly that that means that m is equal to log base a of x and n is equal to log base a of y. So keep that in mind as we go on about proving the logarithm laws. Now I'm going to write down 2 headings for the columns. One is for the index laws and the other is for logarithm laws. And this is because logarithm laws are a direct consequence of index laws and also the definition of logarithms. So index law 1 says that if I've got a to the m times a to the n, I've got a to the m plus n. So logarithm law 1 is saying that if I've got log base a of x times y, and this is the exact same x and y as we've defined above, okay? So that means that it's log base a of a to the m times a to the n. And index law 1 says that that's log base a of a to the m plus n. And by the definition of logs, that's m plus n. And as I said, because they're equations, it goes back and forwards each way. So m plus n is equal to log base a of x plus log base a of y. And because we've got all equations here, log base a of x plus log base a of y is also equal to log base a of x times y. Okay, so don't forget we're using the same x and y as above. All right, let's have a look at index law 2, which says if I've got a to the m divided by a to the n, well, that's just equal to a to the m minus n. So that makes log law 2 being if I've got log base a of x divided by y, then with x and y defined as above, we've got log base a of a to the m divided by a to the n. By index law 2, we've now got log base a of a to the m minus n, which is just equal to m minus n. And because we've defined m and n to be log base a of x and log base a of y respectively, we've now got log base a of x minus log base a of y. And of course, because we've got all equations here, that means that log base a of x minus log base a of y is equal to log base a of x divided by y. All right, next we've got index law 3, which says if I've got a to the m raised to the power of p, then I've got a to the m times p. Oh, I'm just going to go back and fix up this. Yeah, that should be exponential law 2. Apologies. So let's go back to exponential law 3. So basically, if I have a number raised to a power and it's all raised to a power, I multiply them together. So if I'm going to use my logarithm laws, then log law 3 says that if I've got log base a of x raised to the power of p, and then because x is a to the m, we've now got log base a of a to the m raised to the p, or log base a of a to the m times p, which by the definition of logarithms means that we've got m times p. Now for convenience sake, I'm going to reorder that. M times p is the same as p times m. And p is just that number we had for the power, right? But m is equal to log base a of x. So what we've got here is p times log base a of x. So hopefully you're really clear that I've defined this x and y to start with equal to a to the m and a to the n respectively, and we're just continually working backwards and forwards with those. But if you are, it should be obvious then what the first three laws of logarithms are. There's actually some other consequences of exponentials with logarithms. Now, assuming that a is not equal to 1, and it's really important that you do that, because log base 1 is a little bit like dividing 0, and I'll let you think about why that's true, okay? But assuming that a is not equal to 1, then because a to the 0 is equal to 1, and a to the 1 is equal to 0, a to the 1 is equal to a to the 0 is equal to 1, then it follows that log base a of 1 is equal to log base a of a to the 0, which is 0. And log base a of a is equal to log base a of a to the 1, which has to be equal to 1. And of course, we've still got x equals a to the m. Then for this x, if we've got 1 over x, we've got 1 over a to the m, which is equal to a to the minus m. So that means if we take the log base a of 1 divided by x, that's equal to log base a of a to the minus m, which is equal to minus m. And because m equals log base a of x, that means that we've actually got minus log a of x. So that's sort of using index law 3, but you could also look at index law 2 if you really wanted to. And let's think about log base a of 1 on x as 1 divided by x. So that means that we've got log base a of 1 minus log base a of x. And log base a of 1 is equal to 0, right? So that's equal to 0 minus log base a of x. And of course we could ignore the 0, so we've now got minus log base a of x. So that's pretty nice. That doesn't matter which way we approach it, we end up at the same result. It's pretty comforting to know that mathematics is very consistent. Whatever you do, don't read Gödel's incompleteness theorem to understand what the implications of a consistent system is. But moving right along, I want to formally write out the logarithm laws now, and it's up to you to write them down because I'll be using them in the following sections, assuming that you've written them down. All right, let's give it a title. So law 1 is saying if I've got two numbers multiplied together, then the logarithm of that two numbers multiplied together is the logarithms of each number added together. So the second law of logarithms is saying that if I've got x divided by y, then the logarithm of x divided by y is the logarithm of x, subtract away the logarithm of y. So multiplication leads to addition and division leads to subtraction. And moving on to log law 3, the log of x to the n is just equal to n times the log of x. So while multiplication goes to addition and division goes to subtraction, so that means that powers go to multiplication. The other points to make, of course, were those consequences. So log base a of 1 is equal to 0, log base a of a is equal to 1, and log base a of 1 on x is equal to minus log base a of x. I do think that these will eventually become easy for you, but I do imagine now the first time you see them, it is a bit to get your head around. So please, as we always do in a topic like this, pause the video and do the building understanding questions in the new book, which translate to questions 1, 2, and 3 in the old book. And as I said, I'm assuming that you've written down those laws or memorized them. So if you haven't, make sure you write down those laws. All right, I'll see you in the next section. Hopefully you did write down those logarithmic laws because we're going to be applying them in example 4 when we're going to simplify the following statements. All right, part A, we've got log base a of 4 plus log base a of 5. And because law 1 says log base a of x times y is the log of x plus the log of y, and we've got two logs here with the same base added together. So therefore we multiply the things inside the logs together. So we end up with log base a of 4 times 5, i.e. log base a of 20. All right, hopefully that's pretty straightforward. Let's move on to part B, where we've got log base a of 22 minus log base a of 11. And with law 2, the log of a division is equal to a log of subtraction, right? So we've got log of 22 minus log of 11. So we end up with log base A of 22 divided by 11. So the positive one is the numerator and the negative one is the denominator, right? All right, and we can actually divide 22 by 11. So we've got a log base A of 2. And then in part C, we've got 3 times log A of 2. And of course, if you remember law 3, log base A of x to the p is equal to p times log of x. So of course we can go back the other way. So we can raise 2 to the power of 3, which gives us log base A of 2 to the 3. And 2 to the 3 is 8, so we've got log base A of 8. Okay, so that's all we're asking for you in this example, okay? And of course in your pre-learning as well. So just pause the video now and do questions 1, 2, 3 and 4 in the new book and questions 4, 5 and 6 in the old book. And even though it's only really going to ask you to use the log laws to recognize where they are and then apply them properly, but I invite you to try some numbers for A and pop those in your calculator, okay, and see if it all does come out true. Of course, you should know that A has to be a positive number, not equal to 1. All right, we'll see you in the next section. In this section, we'll be applying the logarithmic laws in example 5 to simplify the following logarithms and evaluate, which means that there'll actually be some number bases this time, so we'll be seeing some number answers for our results. Let's go to part A, where we've got log base 2 of 1. Well, this doesn't really matter what base it is, does it? Because log base A for any base of 1 is equal to 0. So that means that log base 2 of 1 is also equal to 0. Part B, we've got log base 5 of 5. Well, because log base A of A is equal to 1, in this case A is equal to 5, right? So therefore log base 5 of 5 is equal to 1. And that's all they're asking, right? 5 to the power of 1 is equal to 5. And for part A, 2 to the power 0 is equal to 1. All right, let's have a look at part C, where we've got log base 6 of 1 over 36. And of course, log base A of 1 over x is equal to minus log base A of x. So that's equal to minus log base 6 of 36. And our final answer is minus 2, because 6 squared is equal to 36. So i.e. log base 6 of 36 is 2. All right, let's go on to part D, where we've got log base 2 of 6 minus log base 2 of 3. Now, if I was to look at these in the calculator, we can see that log base 2 of 6 is some 2.5, quite a few decimal places there. And log base 2 of 3 is, oh, well, there's a lot of numbers there too. So that's no good, is it? So let's think about how we might simplify this. We've got 2 logs here of the same base and one is subtracted from the other. So we can rewrite that as log base 2 of 6 divided by 3. And 6 divided by 3 is 2, so we've got log base 2 of 2, and log base 2 of 2 is 1. There is actually another way of looking at that, and that would be focusing on the 6, right? 6 is 2 times 3, so I'm going to rewrite that as log base 2 of 2 times 3 minus log base 2 of 3. All right, I haven't changed anything there. 6 is just 2 times 3. But using that log law 1, we've got log of 2 plus log of 3. So all we've done is change this log base 2 of 6 to log base 2 of 2 times 3. And now it's log base 2 of 2 plus log base 2 of 3. So that's the same thing all the way down. And of course, we can't forget our log base 2 of 3 there. Now we've got 2 things that are the same here. We've got our 2 log base 2s of 3s. So anything subtracting itself is 0, so they disappear and we're left with log base 2 of 2, which of course equals 1. So as you can see, there's many ways to skin a cat, which this poor guy found out about the hard way. He looks a little bit too cool for his own liking, eh? Alright, so apart from skinning a cat, it's also nice to know that our laws of logs are consistent. Alrighty, pause that video now and do questions 5, 6 and 7 if you have the new book, or 7, 8 and 9 if you have the old book. And then when you come back, we'll be able to summarise this lesson. So I'm sure that you're beginning to see that you can use logarithm laws to solve all types of exponential equations. So make sure that you work on these skills and write down all the laws because they're going to be very important. Because in the next lesson, we're going to start applying them. Alrighty, so for this lesson, a successful student will know how to combine logarithms with the same base using the logarithm laws for addition and subtraction. Know properties of logarithms involving powers and the logarithm of 1. And finally, be able to use these logarithm properties to simplify expressions. Alright, well done. You've made it this far. Just one more lesson to go for this unit, and it really is the whole point of this unit. And I'd just like you to take a moment and think about how far you've come. So even though I'm guessing this will be easy for a lot of you, because they're often fairly obvious consequences of exponentials, you've still come a very long way. Anyhow, keep it up. We'll see you in the next class, either in the classroom or in the next video. Bye.